Chapter number 8, Basic Operators. So far, whatever we have learned about data types and variables, we'll be using it. So Python divides the operator in the following groups. The first one is arithmetic operators, then assignment operators, comparison operators, logical operator, identity operators, membership operator, and bitwise operator. Now, in this course, we won't cover identity and membership operator, but we will cover all the others because the identity and membership, they are in the advanced level, and you will learn once you do the advanced level certification. So for our entry level and associate level certification, we only need the five. So the arithmetic operator, so it is a normal operation, what you will also see in your calculator. So, for example, the plus is addition, no surprise there, minus subtraction, star is multiplication, slash is division, percentage is modulus. So, modulus is where, suppose if you divide 17 by 3, the remainder is 2. So, modulus is 2. Exponential is you multiply the number that many number of times. We'll learn about more about exponential. And floor division, which is double slash, is for example, again let's take 17 divide by 3. So you just remove the decimal number. So 17 divided by 3, like floor division, if we do, the answer will be 5. So we'll learn about this in our example. Next is assignment operators. So we have got 5 assignment operator equal to. So example is x equal to 5. So variable x gets assigned 5. Simple. Now plus equal to. Now this is similar in majority, like most of the languages like C++ and C sharp as well, where x, if I say x plus equal to 3, it actually means x equal to x plus 3. So you add 3 to whatever the x value of x is. The rest of the things will follow in the similar way. So which is minus equal to becomes x minus equal to 3 will become x equal to x minus 3. Same with star equal to is multiplication equal to. So x equal to x multiplied by 3. Same with the division. So I think you got the idea. Um, we'll learn about a few of this example in our example. Next is a comparison operator. Everything here should make sense. So double equal to is used whenever you are comparing two variables. You use double equal to. This is again common across different languages like Java and C sharp along with Python. So double equal to is equal to, and exclamation equal to is not equal to. Greater than is, so this bracket is used for greater than, and then less than, greater than equal to, again it's self-explanatory, and less than equal to. And finally, logical operator, we have got and, which means returns true if both statements are true. uh, or is returns true if one of the statements are true, and not, meaning reverse the result. So returns false if the result is true. So let's have a look at it from example point of view, and it'll make more sense. I've assigned a variable x equal to 17, so we have used equal to operator here. Y equal to 3. Yeah. So I want to show you the example of plus addition, subtraction, multiplication. It's quite easy. So let's start with division, modulus, floor division, and exponential. So let's have a look at this. When we do x divide by y and x modulus y, x floor division y, and x exponential y. Let's run this example and see what happens. All right, so when I do x divide by y, x is 17, y is 3, so I get answer in decimal number. Next is x modulus y, so the remainder is 2, so we got the answer 2. Similarly, x floor division y, we got the answer 5, so it takes out any decimal places, odd modulus, and x exponential y, so 17 exponential 3. So let me show you the example here. So let's do, so 17 multiply by 17 multiply by 17 equal to 4913. So that's what it has done. It has multiplied 7 three times and we got answer 4913. All right, there is our arithmetic operator. Now let's do a bit of assignment operator and then comparison operator. So here our value of x is 17, so I'm doing x plus equal to 2. So I'm saying x equal to x plus 2, so answer here should be 19. Again, here I'm doing a comparison operator, so I'm using double equal to, and I'm saying um, for now just think of this as a if statement. We have got a separate session for the if statement, so just think about it as a proper as a comparison statement. So here I'm comparing, I'm saying if 3 equal to x, the value of x is 19, then print comparison. So because it's not equal, so our comparison should not get printed. Similarly, I'm using an AND logical operator here. X equal to 19, which is true, and y equal to 3. So our value of y is 3, which is again true. So we should get this printed. And an example of not. So print x equal to 19. So we should get a true value here because it's a Boolean value. Uh, let's see. Yep, it will stop complaining, and here also it will stop complaining. So if I save this, so yeah, that's much better. And yeah, here it should. So if I run this again, and let's look at the bottom part. So print x here. So we got a value of 19. This statement didn't get printed because value of x is not 3, so comparison didn't get printed. This got printed, so we got logical here, and is print 19 equal to x. So 19 double equal to x will give us a Boolean value true, and we got true. And then using a not variable, we got the reverse of the true, that is false. So we use this. Next is let's use try and learn about bitwise operation. So bitwise operator, we have got and symbol, which is like it, in bitwise it's and what it does is sets each bit to 1 if both bits are 1. We'll learn about more about bitwise binary representation and then how this bitwise work. So similarly, this pipe symbol is for OR. So it sets a bit to 1 if one of the two bits are 1, and XOR, which is this caret symbol, which is it sets the bit to 1 if only one of the two bits are 1, and tilde symbol, is not, is inverse all the bits. Um, the two less than symbols is shifts it shifts the bitwise representation. If pushing the zeros from right to left. So we'll learn more about that. Similarly, right side shift is 2 greater than symbol. So we'll learn more about this. But before that, just learn a little bit about bitwise representation for the people who are new to bitwise representation of decimal number. So quickly I'll go through it. So on the left hand column here, I am having a decimal number 0 to 15, and on right hand side, I've got a binary number from 0 to 15. So binary is a number where you can only have 0 and 1. So if I want to represent any number here, then I should have a equivalent binary number. Now the way it works is 4 zeros is 0. Um, with 1 is the last becomes 1, and then 1 0 for 2, 1 1 for 3, 1 0 0 for 4, 1 0 1 for 5, 1 1 0 for 6, 1 1 1 for 7, and then the fourth one uh, binary becomes 1 and rest all becomes 0, so which is 8, and so on and so forth. So we have got number till 15. And if the number is 16, then the fifth, you get added the fifth number, and it becomes the binary representation of 16 would be 1 0 0 0 0. So that's the just a quick explanation of decimal and binary. So uh, I put together example for easy understanding of decimal and binary. So I've got three decimal number: A equal to 60, B equal to 13, and C equal to 0. Now the binary equivalent of 60 is this. I've highlighted it, and the binary equivalent of 13 is this. Now you can easily find that out using a calculator. So let's use not the scientific calculator, let's use the programmer calculator. All right, so if I do binary 60, the bin number is binary, sorry, if I do decimal 60, the binary number is 00111100, as you can see here. And same with 13, you can check 13 and you will get 1101. So let me minimize that. Now let's do some operation. So I've done C equal to A and B. So what should happen is A is this, B is this. So if I do A and B, so it should do, so it will compare, um, so this and this is 0. So if I highlight this, so it'll do, so this highlighted one is 1 and this is 0. So answer will be 0. Similarly, this is 1, this is 0. Sorry, this is 1. So answer will be 1. Similarly, this is 1, this is 1. So answer will be 1. Rest all will be 0. So let's run this. So so when I do C equal to A and B, so it is if we go back to our sets each bit to 1 if both the bits are 1. Yeah. So hence the answer is 12. Yeah. Similarly, if I do OR, so if I highlight this and if I do OR of this, so it will be 00111101. Yeah. So as the answer will be this, which will be 61. So as we can see here, um, similarly, if we do XOR, uh, the answer will be, if I highlight this again, it will be, so if we take this, XOR is sets each bit to 1 if only one of the two bits are 1. Hence we got 00110001, and the answer is 49 for XOR. So we'll look at these three example now. One is invert. So it's invert of A. So A is this one. So it'll do the invert of everything. So 0 becomes 1, 1 becomes 0. Also positive becomes negative sign. So hence we got the answer of minus 61. Now the last two example, it's an interesting one. So here we are saying shift A to by two side, bitwise two side to the left hand side. So A is this one, and we want to shift it to side. So 1 1, this 2 1 1 will go to the left hand side, and we'll get 1 1 1 1 0 0 0 0, and the answer is 240, as you can see. Similarly, for right hand side operator, shift right operator, A greater than 2, everything will shift to position to the its right. So the answer will become 15. Yeah, so as you can see, the answer is 15. So that's our bitwise operation. So in this session, we have learned about arithmetic operator, assignment operator, comparison operator, logical operator, and bitwise operator. For bitwise operators, because it's slightly complicated, is interviewer favorite topic. Sometime logical operator is asked. So that's it in this session. Keep practicing, and let's meet in our next section, which is a string. I have provided the links in the description below for the Python and PyCharm download. I have also recommended 3 Python books to enhance your knowledge. If you like this video, please like, comment, subscribe, and share. Thanks for watching.